This is the 7.7 notes for the online trig class, the graphs of tangents, cotangents, cosecants, and secant functions. So we did sine and cosine in the last section. It was all about learning the general shape of those graphs and then learning how they could be transformed. We're going to graph the tangent function in great detail, just like we did sine and cosine, and we'll transform it. And then I'm just going to show you the secant and the cosecant, what they look, and the cotangent, what they look like, and we may do one transformation of one of those. So, like the sine and cosine functions, the following table can be completed like we did before. Remember, the period of the tangent function is pi. It is not 2 pi. It goes 180 degrees before it repeats its pattern. So what we'll do is we'll look for an interval that covers the length, and after that we'll graph the function, which I don't know why there's a blank for that. The values where the tangent function is undefined are represented on the graph by a vertical dashed line, which in math we call that an asymptote. Okay, which is a kind of an imaginary line that we're not supposed to cross. So at negative pi over 2, tangent is actually undefined. If you remember from looking at the unit circle again, because that's the most important thing when you're trying to graph these, here's negative pi over 2 down here. This is the point 0, negative 1. Remember, tangent is y over x. If you put negative 1 over 0, you're undefined. Negative pi over 3 is net down here negative 60 degrees, essentially. And that point down here is 1/2, and then negative square root of 3 over 2. Now, if we do y over x for that, that is negative square root of 3 over 2 over 1/2. You multiply top and bottom by 2, and that's how they're coming up with the negative square root of 3 over here. Anytime you're at a pi over 4, essentially remember that is a 45-45 triangle, and you end up getting the same number over itself, so that actually ends up being negative 1. So negative pi over 4, comma negative 1. The reason it's a negative is because in this quadrant down here, your x's are positive and your y's are negative. Negative pi over 6 is, remember, a 30-degree angle down from the x-axis right here. And that's the reverse of this one, so it's square root of 3 over 2, comma negative 1/2. And if you turn that into y over x, that is negative 1/2 over square root of 3 over 2. You times by the 2, but the problem is you get negative 1 over the square root of 3. So negative 1 over the square root of 3 has to be rationalized. So that actually gives you negative square root of 3 over 3. So negative pi over 6, and then negative square root of 3 over 3. And we will obviously want to get a decimal approximation for 2 of these. We did already for the negative square root of 3, so if you want the divided by 3 part, you would take square root of 3, make that negative, and then divide that by 3. So that's negative 0.58. So this right here is approximately negative 0.58. At 0, tangent of 0, that's happening right here at the point 1, 0. That's 0 over 1, so that would just be 0. So that means tangent crosses at the origin. Pi over 6 is going to be kind of a mirror image of negative pi over 6 because it's the same reference angle up here. The only difference is everything's positive. So this one's going to be positive square root of 3 over 3, or positive 0.58. Pi over 4 is the mirror image of this, again, because tangent, when you're dealing with the angles, it's all based off of y over x, and the y and x are the same here except for their signs, as they were for negative pi over 4. So that's going to be 1, since it's in the first quadrant. And then pi over 3 will be in the mirror image of this, but it'll be positive. And pi over 2 is undefined. And the reason it is undefined is because the point up here is 0, 1, and 1 over 0 is not defined. So what that means for us is And this is an odd function. Remember, tangent is an odd function, so you should expect some of these things that happened with the points where the x value and the y value, whatever they are here, if you changed both signs, that's also on the graph. That's what happens when you have an odd function. So then we plot the points. So those are my two asymptotes. Those are the places that it was undefined. At negative pi over 3, we're down at negative 1.73. At negative pi over 4, we would be at negative 1. At negative pi over 6, we're at negative 0.58. At 0, we are at 0. At pi over 6, we're at positive 0.58. At pi over 4, we're at positive 1. And at pi over 3, we're at positive 1.73. So what you notice is there's actually kind of this, it's not a straight shot. Some of my points are a little bit hard to draw in. It kind of slopes like this, okay? It looks a lot like x cubed, if you remember that from college algebra. But this pattern repeats over and over again, so it is different. So this right here, notice it doesn't go down in a straight line, it goes down at a curve, and this goes up at a curve. So you get this, it almost looks like a parabola that's kind of split in half. One side's down and one side's up. Now what that means for that is that the domain is restricted. You can't plug in any x you want because you have these asymptotes that keep popping up every pi length. But the range is all real numbers. This goes down forever, this goes up forever. Every single y value gets used in this graph. So this is summarized down here. The domain is set of all real numbers except odd multiples of pi over 2. That's every time you add pi to pi over 2 or subtract pi, you get another asymptote. The range is all the real numbers. Tangent function is odd, so remember it has origin symmetry. Other things to note, it is periodic with a period of pi. And then the x-intercepts, if you kept going with the graph over and over again, would be these, and it would continue. And that's every pi is when you get another x-intercept. Same thing for the vertical asymptotes. And the y-intercept is at 0 because of the point 0, 0. So kind of to mirror what we learned in the last section, we're going to take tangent and we're going to do a transformation of it. So we have to remember the things that we've learned. We have to remember about phase shift and vertical shifts, amplitude, any of that stuff. So let me talk you through this one. Okay, so in this specific one we have a phase shift because of the plus or minus inside here. We don't have any amplitude going on or reflection because there's no number or negative up front. We don't have any stretching or compressing of the period. Because there's no number in front of x, but we do have a vertical shift at the end. So the basic function we are graphing is related to tan x. The two transformations involved is a phase shift of pi over 4 to the left, because it's a plus, which means we do the opposite. And then we also have a vertical shift down. So one of the easiest ways, especially with tan and cotangent, is to just move the points that we had above. So this is another way of attacking a transformation. Our points that were of main emphasis, I like to have at least 5. If we have our angle and we have our value, we had, okay, so we had negative pi over 2 was undefined. We had negative pi over, I want to say it was 3. Yes, we did pi over 3, pi over 4, and pi over 6. So negative pi over 3 was square root of 3. Negative pi over 4 was 1. Except these were negative, I believe. Let me double check my original chart. Yes. Negative pi over 6 was negative square root of 3 over 3. and then 0 was 0. Now I'm not going to do all of the positive ones as well, because if I know where these end up, I'll know exactly where the positives are going to end up, because they're going to be the same points but with both signs being positive. Okay, so if we phase shift, that means we move left pi over 4. So that means our x is changing. So if you think about it, negative pi over 2 minus pi over 4, we're going to be moving more to the left. If you get a common denominator there, that would be 2 pi over 4 minus pi over 4. This new theta is going to be, and I'm not going to worry about the values yet, it's going to be at negative 3 pi over 4. So that's actually going to be our new undefined. That part's not going to change. Negative pi over 3 minus pi over 4. That means that we need to get a common denominator, so 12 would be the common denominator, so negative 4 pi over 12 minus 3 pi over 12. Multiply this one by 4 over 4 and this one by 3 over 3. That's negative 7 pi over 12. We'll just do a rough estimate of where that is. Negative pi over 4 minus pi over 4 would be negative 2 pi over 4, which is negative pi over 2. And negative pi over 6 minus pi over 4 would be, get a common denominator of 24, that'd be negative 4 pi over 24 minus 6 pi over 24. That's negative 10 pi over 24, which does reduce down to negative 5 pi over 12. And then 0 minus 4 pi would be, or pi over 4 would be negative pi over 4. Now, the other part that happens is that all of our y's are going to go down 1. So essentially the undefined doesn't change, because that means that we're still dividing by 0. But this would be negative square root of 3 minus 1 more. Negative 1 minus 1 more would be negative 2. Negative square root of 3 over 3 minus 1. We'll get a decimal for that in just a minute. And 0 minus 1, which would be negative 1. Okay, so let's get some decimal values for each of these. So 3 square root, which is negative, minus 1. That's negative 2.73, which should make sense because it was negative 1.73 before. And so we really don't need to do this one because this was negative 0.58. So this would be negative 1.58. Now, I didn't do any of the positives because as soon as I plot these points and this asymptote, I'll know exactly where the other things are going to show up. So in a graph like this, this would be negative, so look, we're counting by fourths. Negative pi over 4, negative 2 pi over 4, so this is negative 3 pi over 4. So that's where my new asymptote has been shifted. It's been shifted pi over 4 away from the original asymptote to the left. And then we start plotting points. So negative 7 pi over 12 is a little bit bigger than negative pi over 2 because this is 6 pi over 12 if you think about what would that have reduced to. So negative 7 pi over 12 is right about here. So we go all the way down to where we think negative 2.73 is. Negative pi over 2 is negative 2. Negative 5 pi over 12, that's just, let's see, because if we were at pi over 4 would be 3 pi over 12, so that's going to be a little bit more this way. And that one is negative 1.58. Negative pi over 4 is negative 1, so I'm actually down a little bit too far there. And then that's kind of the ending part of our, let me clean that one up a little bit. That's the ending part of this side. Now, I said that the points would be exactly the same. That's not quite true. You can't just change the sign of these because we're not centered at 0 anymore, but these signs will be the same. So if you notice, we were taking like little steps of pretty much 2 pi over 12, so pi over 6 over. So equal distance from this, there should be another point. And if you want, you could find all of these, but I'm just kind of giving a rough sketch. At 0, oops, we should be up here at the 0 line. And then at pi, well, let me see, did I count too many? Because we take a half step and then another step, and then we take another half step. It might be better to get the points. I was trying to do the graph without getting them, but I think we might need to, I think though this is right. So let's just check it. If we plug in tangent of 0 plus pi over 4, so that'd just be tangent of pi over 4. So you can always check yourself if you have your calculator handy. So let me do or pi divided by 4, and then take tangent of that, which I'm in degrees. I'm supposed to be in radians. See, you have to watch your calculator. So pi divided by 4, take tangent of that, it's 1, and then you subtract 1. So yes, we are right. 0, 0 is a point, and I just hit an extra thing there, but 0, it ended up being 1 minus 1, so that's 0. So if we wanted to, we could do, we should be almost at the end, because notice this was 1, 2, 3 points from the center. This is 1, 2. So the last point is going to be right about here, because what we have is that there is another asymptote that has to be pi away from the original, because our period didn't change. So from negative 3 pi over 4 to pi over 4 is a distance of pi. So that means our graph had to be contained within that, because that's our period. So notice this has been shifted down, but it still has that general shape. It's just they've made this a little wide for some reason. And then there would be another version of that over here. I'm not going to draw it in completely, but there would be another version that's similar to here, and then we would have another asymptote, because remember, tangent repeats over and over again. So then the cotangent, the period of cotangent is actually also pi, we don't need anything there. The thing about tangent and cotangent, remember, they're reciprocals of each other. And when you reverse so remember, tangent is y over x and cotangent is x over y. That changes where your asymptotes are located. Remember, they were at negative pi over 2 and pi over 2 for tangent. If you flip it, it happens at the other pi intervals. So 0, pi, 2 pi, negative 2 pi. And another thing to note is that the actual shape of that is reversed as well. In tangent, you go up the hill, and in cotangent, we kind of go down the hill. So that's the general shape of that graph. And then like I said, I didn't want to graph each one of these because that it'll make the videos really long. But to graph cosecant and secant, you have to remember that they're reciprocals. Cosecant is 1 over sine, secant is 1 over cosine. And what that means is every point that was on this sine wave here, when you look at cosecant, you take whatever this point is and you actually have to make the y value the reciprocal, because remember, sine is related to y. So the y value here. So when we do that, it would be 1 over 1. And then they show you if you have pi over 6 is 1/2. Then pi over 6 for the other function, the cosecant, would be 2 over 1, so it's 2. That's when we then all of a sudden create asymptotes for the cosecant, because there's this point pi 0 right here, but if you do 1 over 0 for your y-coordinate when you do the reciprocal, that makes an undefined value. So every pi, so at 0, pi, 2 pi, negative pi, and negative 2 pi, you are also going to have those asymptotes. And what you end up getting, so remember, this wave right here is not part of the graph, it's just to show you how they've figured this out. What you end up getting is, since these can't continue through because of those asymptotes, you get these little kind of parabola shapes. Same thing for secant. Secant is related to cosine, so notice we're looking at the cosine wave now. And again, it's just the reciprocal of all those y values, because we're just saying whatever was the value before, it's 1 over that. So pi over 3, it was 1/2, so pi over 3 would be 2 over 1, or just 2 for the secant function, which means at pi over 2, which is where you normally would hit 0 for the y value, 1 over 0 again would create an undefined. So we get at pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. You get these asymptotes. So something interesting is that tangent and secant have the same restrictions, and cotangent and cosecant have the same restrictions for their asymptotes. So there's some interesting relationships there. And that's all based on what variable is in the bottom, because tangent is y over x and cosecant is 1 over x, because it is, or excuse me, 1 over y. Did I say that right a second ago? Secant is 1 over x. So let me write that out, because it's good to talk it through, but it's better to relate it. So secant of theta, remember, was 1 over, because secant is related to cosine, is 1 over x. Tangent of theta is y over x, which means that both of these have the same restrictions, because they both have that x in the denominator. Whereas cosecant of theta and cotangent of theta, that is 1 over y and x over y. Because of the y in the denominator, they also have the same restrictions for their asymptotes. So that's why that is the way it is. And then this last piece is I wanted to graph one more function just from general shape. So let's just do a rough sketch of the original cosecant. And what I'm going to do is just go back up here and remind you of what that looks like. Remember, at 0, pi, 2 pi, negative pi, and negative 2 pi, we have these asymptotes. And notice on the right side of the y-axis, it's up, but on the left side, it is down. We're going to use that as our gauge for what we're trying to graph so that we see kind of the repeating pattern of up and down. So let me just roughly sketch that down here. So remember, here's 1, here's negative 1, and at pi over here, we have an asymptote. At negative pi, we also have an asymptote, and we also have one at 0. So x equals 0, that's an asymptote as well. And on this side, you were up, so you were at 1, and then it went up on both sides. And on this one, we were at negative 1, and we went down on both sides. So let's then talk about these transformations here. Okay, because of the negative out front, that's going to flip the shape. So that means now we're going to be up on the left, but down on the right. Okay? The other thing that's going on here is a phase shift. This is going to be a positive pi over 2 or right pi over 2. So what we have to think about is what is that going to do to our asymptotes first, because if you can figure out where the asymptotes are, then you know what the graph's going to do. So if you have pi and you add pi over 2 to that, think about getting a common denominator, make pi 2 pi over 2, that's still pi, and that's going to be 3 pi over 2. So my first one is at 3 pi over 2, which is right here. That's my first new asymptote. If you add pi over 2 to 0, you'd be at pi over 2. This is a very tiny graph. If we were at negative pi before and we add pi over 2, we're going to be at negative pi over 2 from that. And we could keep going with this. Essentially, notice it's going up every 2. So if I want to, I could continue this on and show the pattern. Now, because of the flipping, remember this guy is the one that used to be over here. This used to be down, now it is up. So that means this first one starts, and there was no moving up or down, so I'm still at 1 and negative 1 for my values. And there was also no amplitude number up here. And then down here, we would be at negative 1 and down. And this would continue alternating all the way across. And you could keep going forever. So ... And that is the end of the notes for this week.